Alright, we need to look at ratios in terms of tan theta on 2, and we say that t equals tan theta on 2. And we've got a rule for tan theta, which is 2 lots of t on 1 minus t squared. There's one for sine. You don't have to remember these, they're on the formula sheet. 2t on t squared plus 1, and there's one for cos, which is 1 minus t squared on 1 plus t squared. Now the start of this little video goes through where they come from. So for tan 2a, why have I chosen 2a? Because 2 times theta on 2 gives me plain old theta. So if I say that 2a is 2 tan a on 1 minus tan squared a, which you know, and sub in the theta on 2, I replace that with t, and I get a rule that looks very similar to the tan double angle. With sine, if I use tan, theta on 2 is t on 1, then I get the hypotenuse over here. But I want sine theta, which is, again using the double angle, 2 sine a cos a, which is 2 sine theta on 2, cos theta on 2. Well, I know that sine theta on 2 is t on 1 plus t squared square root, and I know that cos is 1 and the root of the hypotenuse, and if I put them all together, I get the proof. The same with cos. Cos 2a is cos squared minus sine squared. So cos theta, which is 2 lots of theta on 2, is cos squared theta, which I've got from the triangle above, minus sine squared theta, and when I put it all together, I get the rule. But as I said, they give you the rule. Let's have a look at using the rule. Find the exact value for 2 tan 15 on 1 plus tan squared 15. I recognise the rule as being 2t on 1 plus t squared, which is sine. So I say sine 2 lots of theta on 2, which is theta, is 2t on 1 plus t squared. Well, what is theta on 2? In this one it's 15. So it's equal to sine 2 lots of 15